Hi, my name is Gibson and I'm going to talk about my planet. First of all, we should talk about what is life. Well, not only is it a George Harrison song released in the 1970s, but it's also described as a system that is able to perform functions such as metabolizing, excreting, respiration, growing, moving, and reproducing. Of course, there's a lot of exceptions to this definition because we know that they're microbes that are non-motile and etc. These descriptions contain a summary of what we know about life, as reproduction can become sexual asexually and can happen through binary fission, budding, fragmentation, parthenogenesis. And these methods vary in order to adapt to their environment and have a higher rate of survival, thus indications of evolution of life. Life as we know it is made up of DNA and through this carbon, and it's found in the present and past of all life as we know it. It's part of our genetic makeup. Chemical and metabolic processes such as anaerobic reactions that form substances and catabolic reactions which break down substances are major determinants of giving life. Specifically, photosynthesis, transpiration, and respiration for plant phylum, and other processes such as fermentation, glycolysis, and the citric acid cycle are essential for animal phylum and microorganisms. Further on this, we need to know about the habitability criteria for our planet. And we need to know, can we evolve life on this so-called planet that I'm still trying to name? I will decide by the end of the video. But as NASA describes, that a planet that can sustain life for a significant period of time and mainly requires the planet to have liquid water. And we now know that a lot of planets have periodic habitability through this. And this is because of their orbit around their suns and stars and how they have a limited period of sunlight and temperature fluctuations and all that kind of stuff. Whenever I think of life, my mind goes straight to soup. What flavor? Primordial. This theory summarizes that within minimal oxygen, large quantities of hydrogen, methane, ammonia, and other gases accumulated in primitive bodies of water with the addition of energy through forms of light, heating, UV rays, results in the precursor of life, monomers. Pause for effect. Later, these can form polymers that are the precursor for complex organic molecules. These are made up of essential gases of carbon and hydrogen and other additional gases like nitrogen, oxygen, and more. As we know, oxygen is an essential molecule used in respiration in most chemical processes that drive metabolism in most complex organisms. With it, we need life to evolve. NASA concluded that an oxygenated atmosphere can serve as a beacon for microbial life and fuel metabolism of large organisms, which is why it is crucial and present in my planet. And hopefully I can put the reference somewhere here and another one here. We also need to talk about the changing atmospheric conditions that can influence a planet's habitability. Let's have a count of how many times I can't see habitability. So obviously there's a lot of conditions that can throw the planet's perfect design on its head. Gravitational interactions with stars, moons, and other planets can affect the degree of tilt, spin, and orbit. They can completely change the amount of solar energy that the planet needs to thrive off. In turn, it could mean that less light gives less energy for the planet, like photosynthetic organisms and plants to thrive. The increase or decrease of sunlight correlates to what the planet can absorb, dictating the temperature and creating a domino effect of the forms that water can take, like liquid water, which we want, ice, and I don't know if boiling water is an option, but it doesn't sound great, which we know is the main factor for determining habitability. With low sunlight comes low absorption, creating low temperatures, ice cover and snow cover, which then reflects the light further, causing the decrease of temperature, limiting the options for habitability and creating this positive feedback loop that I don't want on my planet. Another factor that can affect surface liquid water and the potential for life is sourced from the Handbook of Exoplanets, which actually exists. It highlights how pressure, greenhouse gases, clouds, hazes are known to change atmospheric thermal structure, temperature, and create a gaseous layer like our ozone layer for protection. So in my theoretical planet, there would be a higher pressure atmosphere, meaning it would be dense with gases allowing stable transport of heat. It also promotes the creation of gaseous layer that will improve the conditions for microbial life. For example, it's found that the doubling time of bacteria increases the influx of pressure at specific temperatures. So if I sound weird, I have to have a lozenge because I am fighting to survive. Anyways, we should talk about the compositional characteristics of what my planet will look like. Because we know that water is thought to be the secret of life, why not make 80% of the planet's surface liquid water? Now, this is a very accurate and definitely to scale diagram that I have made. It's definitely not rock melon, so don't worry about it. And these are the tiny little islands. So the green is going to be the water and the pink is going to be the islands. So within the 80% of water on the surface, there'll be small islands, land masses, distributed evenly across the surface. They'll have traces of calcium and manganese aligning with the rock mineral makeup of rocks commonly found near large bodies of water seen on Earth and Mars. These small islands would be most similar to limestone and dolomite and would continue to build up all these They'll continue to build up all these hydrated minerals and continue to grow and thrive. In summary, this planet is going to be a high pressure system with a slightly thicker atmosphere, mostly made of organic molecules, and would have a decreased level of oxygen. This means that it could function within the same distance and size as Earth to ensure similar seasonal changes and stable light distribution. According to Google, the diameter of Earth is 12,740 kilometers. So let's make it a little bit bigger, say 300, no, that's completely different, 13,000 kilometers. And if the Earth is 148.46 million kilometers from the sun, let's make ours, this is going to be the sun, not to scale. We're going to make it a little bit bigger so that the distance can decrease. So it'll be about 135 to 140 million kilometers. So like, there. This is a workout. My planet would also have its own limitations because if I'm reducing oxygen levels, that means the atmosphere thins, allowing more UV rays and light to reach the planet, creating more moisture, humidity, and the amount of water on the planet will cause a significant amount of evaporation because of my 80% of liquid water, which means there'll be higher concentration of greenhouse gases causing temperature to rise. So if that does happen, then maybe it means that water will evaporate and completely reveal the rich mineral clay and mud underneath that could be perfect for microbes to thrive and for life to evolve. Or alternatively, I'm God in this situation, so I can keep the atmosphere somewhat dense, but with higher oxygen levels, more than Earth, hopefully. Purely because I'm hoping that in a couple million years, life would evolve to megafauna and megaflora, because who doesn't love that? And that is the main goal for my planet to get to. I'll add some compositional changes and characteristics to the planet, like hydrothermal vents on the ocean floor, potentially producing habitats for microorganisms similar to Earth that don't rely on sunlight nor high levels of oxygen, increasing the diversity and aiding in evolution. I also definitely want to have volcanoes, which give the planet hotspots, help maintain life-inviting temperatures, help regulate the atmosphere's gases and gas cycling, and add a source of carbon which is needed for the assembly of complex organic molecules. Similar to Earth, my planet will be on a tilt, causing the ice poles to my planet because the sun wouldn't be reaching it, hopefully. Let's hope. So it will occur in the North and South Pole, and this has an upside because it makes it easier for scientists to gather samples as well as encapsulating biosignatures that are within the ice deposits, hopefully if evolution is successful. And it's not looking too good because my islands are falling off. In the Goldschmidt conference with NASA, they modeled Earth with the changeable variables such as day length, surface pressure, and orbital systems. They found, quoted by Megan Bannett, who was involved in the study, greater tilting increases photosynthetic oxygen production in the ocean in their model, in part by increasing the efficiency with which the biological ingredients are recycled. The effect was similar to doubling the amount of nutrients that sustained life. I'm 80% sure I said half of that wrong, but I hopefully can quote it up here. Hi, this is Future Ava editing, and I realized I didn't talk about moons. So, I would have 2 small moons similar to Mars that wouldn't be large enough to create an effect in the gravitational forces and tilt. So they'll just be chilling there, and also it would look like the moons from Rogue One Star Wars movie, and I want that. So continue, Ava. And that concludes what my planet is, and I have decided to call it Melotronus due to its looking like a melon. I hope you enjoyed, and I hope my cold wasn't too annoying to listen to. Thank you. Bye.